Hello students and welcome to Smart Case Tutorials. In this video, we will be solving questions which usually come in the papers on logarithms, just the multiple choice questions. There was a request from many of you all to do problems on logarithms for MCQs as well as for 3 marks problem. So that will be a separate video. I'll be doing a separate video for 3 marks question. This is only for MCQ questions. So the different types of questions that you will see in this video are good enough to get you your marks in the upcoming examination. So whatever questions I've solved here, if you can solve those questions and revise those this type of questions, then you will be able to answer the MCQs on logarithm. So let's first begin with the first question. It says the value of log of 800 minus log of 8 is dash. So log of 800 we've got minus log of 8. This can be written in this form, log of 800 upon 8. Now we've learned this rule which says log of m upon n can be written as log of m minus log of n. So I've just used the reverse form of that. So log of 800 minus log of 8, which is log of m minus log of n, can be written as log of m upon n. Now we can divide this and we'll get 100. So 8 ones are 8 followed by 2 zeros. So we get log of 100. Log of 100 can be written as log of 10 raised to 2. Because 10 raised to 2 is 100. Now this can be written as 2 times log of 10. And from here to here is in this form. Log of m raised to n can be written as n times log of m. So the power comes over here. Okay. So log of 10 raised to 2 we can write as 2 times log of 10. Now log of 10 is 1 because it's actually log of 10 to the base 10. See this, wherever the base is not given, we assume it is 10. So log of 10 to the base 10. And the answer comes 1. Why? Because we also have a rule which says log of a to the base a is equal to 1. So 2 into log 10 is 2 into 1, that is equal to 2. So this is how you solve this problem. So the answer over here should be 2. Next question. If log of x minus 7 to the base 5 is equal to 1, then x is equal to what? Now, you should know log, we say log of a to the base a is equal to 1, correct? So the base should be the same as the log. So over here, in this case, we see the value of log of something to the base 5 is equal to 1. Now in this case, both should be the same value, and that is why it comes equal to 1. So that means this value x minus 7 should be equal to 5, because what we would have got 1 how? This way. Log of 5 to the base 5 we would have got as 1, right? So that means x minus 7 should be equal to 5. And in that is the case, minus 7 if we take on the right hand side, it will become positive. 5 plus 7 is 12. So that means x is equal to 12. That means the correct answer is 12 over here. Bar 4.7622 divided by 2 is what? Now we can divide this. Bar 4.7622 divided by 2. So 2 2s are 4. So bar 2 will come because there is a bar 4. 2 3s are 6. Carry 1. So 2 8s are 16. 2 1s are 2. 2 1s are 2. Okay. That means the answer is bar 2.3811. That is how you divide this thing. Next question is, if log of 0.003589 is equal to bar 3.555, then antilog of 2.555 2.555 is what? You don't need the log table to find out the antilog of 2.555. Okay. The reason this is given is to tell you that the value is here itself. And if you see they're matching. 3589 is here, 3589 is here, 3589 is here, 3589 is here. What varies is the decimal point. And for that, all you need to do is look at what number is there before the decimal point. It says 2, right? So 2 to that 2, if you add plus 1, you'll get the characteristic. These are the characteristics. Don't look at the mantissa. Just look at the characteristic. So 2 plus 1, 3. That means you should have your decimal point after 3 numbers. So that should be 358. See, when you remove a log, let's say log of some number, let's say log of 1, 2, 3, 4. Okay. First thing you'll do is look to remove the characteristic of this. So because there are 4 numbers and there is no decimal point, you will say the characteristic is 3. You say 4 minus 1. Okay. Decimal point, whatever the number. Let's say, I don't know, I have not removed I don't have the log table here with me. So I have not removed the log. So let's say I'll assume it is somewhere like say 4, 2, 3, 1. Let's say. That is the answer. That is not the answer, but I'm just assuming. Okay. So log of this is this value. Now if you take the antilog of this, it will give you back. So antilog of 3.4231 will be 1234. Okay. So that is, so log of what? Log of x is y. So antilog of y will be x. That is what it means over here. So we are given log of this number is this. Log of x is y. Now antilog of y should give you back x, right? But what they have changed is, instead of the bar 3, they have now put 2.555. Now we are looking for antilog of this. That means it is no longer going to give you 0.003589. Okay. Here you were getting bar 3 because there are 2 zeros. To that, minus 2 minus 1 gives you minus 3. And that is why you get bar 3 over here. Now in this case, you have 2. So 2 plus 1 will give us 3. So that means 3 decimal places. So you don't have to look at what will be the antilog. Just look for the 3 decimal places and you get 3589. So 1, 2, 3. And so correct answer is 358.9. So we have question number 5. It says antilog of bar 5.7261 equal to dash. And here we have the answer. Now you can take the log table and find out, but without a log table also it's possible to find out. Okay. If you notice, this value is the same, 5322, 5322, 5322, 5322. Okay. What matters is the location of the decimal point or maybe the power. Now it says bar 5. Okay. So whenever there is bar 5, remember it will be 10 raised to minus 5. Okay. If it was bar 4, then it would have been 10 raised to minus 4. If it was sometimes you have bar 50. I'm just saying bar 50 means 10 raised to minus 50. You don't have to bother about writing or moving the decimal point so many places. Just remember, whatever bar comes here, that same number comes. So antilog of whatever bar is given, it is always 10 raised to that particular number. So it is 10 raised to. So we can rule out this one and this one. So this, our answer is not in this two. It has to be in one of these. Okay. Now, the other trick to remember is that whenever a number is, whenever you raise this up to 10 raised to minus 5, 10 raised to minus 5, okay, it will be never in this form, any other form. Always the decimal point will come one number to the right of the first number, first digit. Okay. So 5322 is our number. Okay. If we raise it to 10 raised to minus 5, then our decimal point always has to come over here. You can do it the long fashion way, the long cut way, whatever you can want to say, and you'll get the same answer. This is a trick to identify which one is your correct answer and move faster. Otherwise, you can find out, can take a logbook, find out the value of 7261, which will come 5322, and then bar 5, then you move the zeros so many places and see what it comes. Again, even after you move the number so many places, you will find that your answer is not in this. Why? Because they have given it 10 raised to some power over here. So again, you'll have to bring it in this form. So that will consume a lot of time. Rather, the easier way is to follow this trick. Whatever number is here, Antilog of whatever bar is there, then it is raised to that particular value. So Antilog of bar 5 will be saying that number into 10 raised to 5. Again, when you do that 10 raised to 5, the decimal point should always be one place ahead. Okay, one place after the first digit. So 5.322. In place of 5322, if there was any other number or anything else, any power, same thing would have happened. We always write some digit, then point, followed by how many numbers are given after that, into 10 raised to the power, which coincides with the bar, the number under the bar. Okay, so the correct answer is 5.322 into 10 raised to minus 5. You want, you can find out the answer the long cut way also, but it will only consume more of your time. Next question, log of 4 plus log of 25. We can rewrite this as log of 4 into 25. Again, this follows the rule of log of m plus, actually log of m into n. This can be written as log of m plus log of n. Okay, we had done m upon n and got it as log of m minus log of n in the first question. In this case, it is log of m into n, which we can write as log of m plus n. See, multiplication goes with plus, addition operation, and division goes with minus. See, both, if you want to remember which goes without, remember, multiplication and addition both increase the number or sum of number, whereas division and subtraction always look to reduce the number. So they go hand in hand. So here, now we have got this. Next, we multiply what is there. 4 into 25 gives us 100. Log of 100 can be written as 10 raised to 2. And this we have done previously. So this can be written as 2 times log of 10. Log of 10 to the base 10 is 1. So 2 into 1 gives us 2. So 2 is our answer. Log of 32 to the base 4. We can write this as log of 16 into 2 to the base 4. Now we can separate this out. We can say this is log of 16 to the base 4 plus log of 2 to the base 4. Now, log of 16 can be written as log of 4 square to the base 4. Do not forget the base. Always write the base if there is one mentioned. And log of 2 we can write as log of 4 to the base 4. Now, explain over here why I took what I took. Now, I've got log of 32 to the base 4. Now, the only operation at your level that we know is if we can get the number over here the same as the base. In that way, we can say that if we can show that this is log of 4 to the base 4, then it will come 1. So, somehow we should show this 32, we have to break it down in such a fashion that 4 comes here such that it goes with the 4 at the base. Then only it will become 1 and we can proceed with the operation. Otherwise, we will not be able to proceed with the operation. So, there are different ways you can get. The first thing that came to my mind was 8 into 4. But then I thought, okay, I've got 4. That is okay. So, let's say if I had put it log of 8 into 4 to the base 4. Fine, log of 4 to the base 4 would have given me 1. But how do I manage log of 8 to the base 4? Okay, then that would have been difficult for me. I would have got log of 2. Again, I would have to break down that 8 into 2 into 4, but log of 2 would have remained. Okay, so anyways, 2 is remaining. So in that case, I said instead of going that long cut way, why not do 16 into 2? Okay. So you would say, what good is 16 into 2 and 8 into 2? We are still getting 2. True, we're getting that. But we, I'll, we are skipping one step, or we are reducing one step, you can say, by taking 16 into 2. Because directly we are putting 2 to the base 4 and 16 to the base 4. Now 16 we can write in terms of 4. 4 square is 16. So that is why I put 4 square. Now this 2 we can take out and it will become 2 times log 4 to the base 4. So that is what I'm going to do here. 2 times log of 4 to the base 4. Now 2 to the base 4, you will wonder now what to do. I needed 4 over here and I've got 2. I can't increase the number. But we can write 2 as square root of 4 because square root of 4 is 2. Now square root of 4, we needed 4. The reason for coming from here to here is to get 4. Now this square root has a power of half. So this same square root of 4 is equal to 4 raised to half. That is the value of this square root, half. So in other words, if it's as good as saying log of 4 raised to half to the base 4. This power that you can bring here. And that's what I'm going to do now. I can write it as half log of 4 to the base 4. Now this is easier operation. Okay, so 2 times into 1 plus half into 1. Now this is your normal addition. So 2 into 1 gives us 2 and half into 1 gives us half. And this will end up getting as 5 upon 2. That is our answer. Okay. So remember, whenever you get a problem like this, first thing that should come to your mind is, how can I make the number over here the same as the base? Don't force it, but look at ways. You'll get different ways. I was getting 8 into 4. I didn't find that very appealing. So I will try it with 16 into 2. Okay. And that became, for 8 into 4 also you could have done, but that would have made the problem longer. Remember, you don't have marks for working for the MCQs, directly for the answer. So why waste so much time? And that too, you have got just 1 mark. So try to save time. Don't try to waste time. Okay, our next problem is log of 4 plus log of 5 plus log of 2 plus log of 25. Now we can rewrite this in this form: log of 4 into 5 into 2 into 25. So I told you log of m into n we can write as log of m plus log of n. Okay, so that's what I've done the reverse way. So log of m plus log of n plus log of o plus log of p, we can write as log of m into n into o into p. Okay, so we've got this. Now we just multiply inside and we will see what we get. So 25 into 2 is 50 and 4 into 5 is 20. So basically it's as good as multiplying 2 into 5, which will get 10 followed by another 2 zeros because this is 50, right? 50 into 20 gives us 1000. So log of 1000. Now this log of 1000 can be rewritten as 10 raised to 3. So log of 10 raised to 3, and this we can write as 3 times log of 10, and the base is 10 and is not given, it's 10. So that means 3 into 1, which is equal to 3. That is the answer. The next question is 1 by 3 into log of 27 to the base 3. Now 27 goes in 3 times table, 3 cube is 27. So we'll do that. 1 by 3 log of 3 raised to 3 to the base 3. So that means I can rewrite this as 3 upon 3 log of 3 to the base 3. This will cancel. Log of 3 to the base 3 is 1. So that means the answer is 1 in this case. Our next question is log of 3 to the base 2 minus log of 24 to the base 2. See, the bases are the same. That means we can carry out the operation which says log of m upon n is log of m minus n. Same thing which I had done before. Log of m upon n can be written as log of m minus log of n. Okay, and we can write this in that fashion itself. So equal to, but remember the base, do not forget to write the base because the base is different. It's not your natural logarithm base. So you write over here log of 3 upon 24 to the base 2. We can cancel here 3 ones are 3, 3 8s are 24, and we'll get log of 1 upon 8 to the base 2. Now next, we'll separate this out. You can say log of 1 to the base 2 minus log of 8 to the base 2. Okay, log of m upon n is equal to log of m minus n. Now log of 1. Okay, now how do we manage? We need to get 2 over here. That is when we'll get 1. It has to be log of 2 to the base 2. Okay, that's what I told you previously. So how do we get 2? Okay, so we square root of 2 is not equal to 1. But what is equal to 1? And at the same time, we also get 2. So the answer is log of 2 raised to 0 to the base 2. 2 raised to 0, anything raised to 0 is equal to 1. So then why not write 2 raised to 0? Because 2 raised to 0 is equal to 1. I want 2. Okay, and that is why I have taken this value 2 raised to 0 minus log of 8. 8 can be written as 2 raised to 3. Remember, some of you all make a mistake. You'll multiply 2 into 3, 6. 2, it's not 2 into this 2 raised to 3. The power tells you how many times that number gets multiplied. So 2 raised to 3 is actually 2 into 2 into 2, which is not 6 but 8. 2 2s are 4, 4 2s are 8. The power tells you how many times that number gets multiplied. Okay, you don't multiply that number with you don't multiply the number over here with the power. Okay? So we've got here, and not forget the base. Now we can say this is 0 into log of 2 to the base 2, and this one will be minus 3 times log of 2 to the base 2. Now 0 into anything is 0, so we don't have to bother about anything else. Minus 3 into 1, because this will become 1 now. Log of 2 to the base 2 will become 1. So that means our final answer is minus 3. So since we've reached halfway through the video, okay, because there are a total of 20 questions in this, I've taken these questions from the Maths Level 1 Rajam's preparatory. You can go through that and see. The working is not there. The answers have been given for the first 9 sets. Okay, thereafter there is no answer and there's no working at all. And there's a model paper also. So I've the model paper I've already solved previously. You can go through the videos and see. I can put a link also to the model paper. You can see how it is done. So in this case, these questions, the type of questions are more likely to come. The same question will be repeated with the same numbers. That is highly unlikely. Can come. I'm not saying will come or cannot come. Can come. Okay. But the type of questions that I have covered in this video or that is done in the preparatory, you can expect those type of questions only to come. Okay, and if you have liked watching the video, please hit the like button. Share this video with as many friends and classmates. They will also benefit. Logarithm is for the first time for SSC, and so there is nothing in the past to go back to have a look how logarithms previously, much before, logarithms used to be there. Then Goa Board removed it. Now they have put it back into that, but this is the first time that SSC is appearing for a paper that has got logarithms as a chapter. Okay, so because of the fact that you all requested, I made this video. I hope that you find this video useful. If you haven't subscribed to the channel, please do subscribe to the channel as well. Let's continue with the next 10 questions. 11th question, antilog of 2.421 is equal to dash. Again, what I told you before, just look at what number is there before the decimal point for an antilog. Okay, and the numbers is going to be the same over here: 2636, 2636, 2636, 2636. The difference between all four is the location of the decimal point. Now, because it's 2, the decimal point should come after 3 digits. So this one should be is the correct answer here. Not should be, is the correct answer. 263.6. Okay, 263.6. Because if you take the log of one way to find out whether you're right or not, most of you all will be well versed with finding the log or finding the characteristic. Then to go reverse from antilog, that could be confusing to some or most of you all. So in that case, after you have chosen your answer or put down the decimal places, whether it is for 1 mark MCQ question or whether it is for 3 marks question, always try to find out, if you were to take the log of that particular thing or number, then what would be the characteristic. So if I say log of 263.6, what would be the characteristic? 2. How did you get that? 3 digits minus 1. That gives you 2. That is over here. Right? So that means your answer is correct. What if you have to take this one as the answer? Log of this, the characteristic would be what? Bar 1. What in case of this one? Log of this, the characteristic would be what? 0. In this case, characteristic would be what? 1. Why? 2 minus 1. So the number that you can see over here is 2. So that means the correct answer is 263, because 263 gives your characteristic, that is 2, which we find over here. Okay. Next question, 3 into log of 8 to the base 4 minus 3 into log of 6 to the base 4, okay, is what? Now in both the cases, you have the bases as 4 and they are both multiplied by 3 in both the cases. And the choices given are here over here, as you can see in front of. So first thing I did from here was, I'll rewrite this thing so we can solve this. 3 times log of 8 to the base 4 minus 3 into log of 6 to the base 4. First thing, I took this 3 common. Okay, so that leaves me with log of 8 to the base 4 minus log of 6 to the base 4. Next, I brought it into log of m into m upon n form. So 3 times log of 4, 8 upon 6. This form. Okay. Now, 2 3s are 6, 2 4s are 8, and we get 3 times log of 4 upon 3 to the base 4. Now we rewrite it into log of m minus log of n form. So 3 times in the bracket log of 4 upon to the base 4 minus log of 3 to the base 4. This is easy to manage. Log of 4 to the base 4 is just 1. So we can either write this as 1, but I see that if we don't want it into a number form, we rather have to leave the answer into the logarithmic formula. So I might as well continue with this. Now the same thing can be written once again as 3 times log of 4 upon 4 minus 3 times log of 3 to the base 4. 4 to the base 4, 3 to the base 4. Now this is in this form. See, we usually get this log of m to the base n can be written as n times log of m. Right? Now what we see over here is in this form. We need to convert it to this form. That means the power has to go back to its original place. So this can be written as log of 4 cube to the base 4 minus log of 3 cube to the base 4. Okay. Now log of 4 cube is 64 to the base 4 and log of 3 cube is 27 to the base 4. This can be rewritten as log of 64 upon 27 to the base 4. And we have that choice over here. This is the choice. Now you can do it in different ways, because this is a simpler way. Otherwise, the way I had done it previously was directly take this, from here, I had directly gone here, meaning instead of doing this, I had directly gone and done this thing, log of 8 cube to the base 4 minus log of 6 cube to the base 4. In this way, I would have got this way. I'll show you the other way as well. Okay, so whichever way you feel is shorter, you can do it that way. So I'll just turn the page and I'll show you how you do the other way. So log of 8 to the 8 cube to the base 4 minus log of 6 cube to the base 4. Now this, rather than finding out what is 8 cube, and I just did this way, log of 4 in brackets. So it is m upon n, right? So m upon n. So that 8 cube upon 6 cube. Now this we can write as log to the base 4, 8 into 8 into 8 upon 6 into 6 into 6. 2 3s are 6, 2 4s are 8, 2 4s are 8, 2 3s are 6, 2 3s are 6, 2 4s are 8. So that means you get log to the base 4 cube upon 3 cube, and this will be log to the base 4 cube is 64 and 3 cube is 27, and you get the answer. So short. Okay, whichever way your thinking goes, that is what matters. You can say, okay, this was short, why didn't you show me this first before? But the way you solve and you see a problem, the way you see a solution to a problem is different. You can see it this way or you may see it this way. Okay, both ways are correct, but it all depends on how many problems you have solved and how well you have adapted to those type of problems. That determines how quickly you can solve them and which different ways you can see to solve it. Same thing happens even with riders. Okay, one person can solve a rider in one way, another person can solve a rider in another way. One may be shorter, one may be longer. Both reach the same destination, but through different roads. So that depends on how much you have revised that particular chapter or that topic and how well versed you are with it. That will immediately show you the route. Okay, so during the exam, which question comes, which way you see it at that particular time, what are you thinking, all that matters. Next question number 13, par 7.9431 divided by 3. Write it in division form, proper division form. So equal to 7 bar 7.9431 divided by 3. Now, this is bar 7, okay, not a positive number, so we can't divide it directly. Okay, so we have to convert it. We can't make it positive, but what we can do is make a number, get a number over there that is divisible by 3. We can't reduce the number, so we can increase the number, reduce the number only, but to avoid the confusion, what we can see, the next number I can see divisible after 7 is 9. 3 3s are 9. So how do we make it as a bar 7? Making it how can we make it bar 9? Making it bar 9, bar means negative number. So that means we'll have to add an again negative 2 to this 7 to make it negative 9 or bar 9 in terms of logarithm terms. So I'll separate this out first, okay, so that you understand, okay, otherwise you can directly do it. So I'll separate it out as bar 7 plus 0.9431 whole thing upon 3. This means this. When you add this to this, you'll get bar 7.9431. Okay. Now next, we want this as bar 9. So for that, we'll have to add it to negative 2. To balance this negative 2, because there's no negative of 2 over here. So in order to balance this and to make sure there's the entire equation over here does not get disturbed, we add a plus 2. Minus 2 plus 2 is what? 0. So it doesn't interfere at all. We need this minus. Why are we doing this? Because we need a minus 2 to go with this 7. Why do we need that? Is because we need a bar 9. Why do we need a bar 9? Because we need it to divide with 3. Okay. So plus 2 plus 0.9431 whole thing divided by 3. Now bar 7 minus 2 will give us bar 9, and straight away I'll separate it out as upon 3 plus 2 added to 0.9431 gives us 2.9431 whole thing upon 3. Okay. A, usually we do A upon, let's say, A upon M plus B upon M. How do we write this in addition terms? A plus B upon M. Okay. This number here tells you that this number is common denominator of A as well as B. What we can see over here. So same thing I have done over here. 3 is a common denominator to all of these numerators over here. So I've added them and I've got bar 9, and to that bar 9 I've put down 3, because so if we add this, we can do this and we'll get bar 9 plus 2.9431 upon 3. So I've just separated out because I want to divide. So here we'll get 3 1s are 3, 3 3s are 9, and remember this will be bar 3, not just 3. Okay, plus, and then we divide this. So 3 into here, this will become 0 because not divisible by 3. 29. So 3 9s are 27, carry 2, 24. 3 8s are 24. Okay, and 3 1s are 3. Here there will be 0. No need of carrying out further division. This much is enough. Okay, so we've got 0.9810, and we've got bar 3. Now this bar 3 will add to this, and we'll get bar 3.9810. This is our answer. Okay. Next problem, if log of 3 equal to 0.4771 and log of 10 equal to 1, then log of 90 equal to dash. Log of 3 has been given, log of 10 is given as equal to 1. Then we are asked to find the log of 90. Now the first thing that I see over here is 10 is given. Why is 10 given? That should strike you. Okay, and what is 90 got to do with 3 and log of 10? Then the first thing that comes to my mind is I can write log of 90 as 9 into 10, correct? And 9 is a multiple of 3. So let's see where it takes us. So we say log of 90. We can write it as log of 9 into 10. This we can rewrite as log of 9 plus log of 10. Correct? Log of 10 we've got as 1. Log of 9 can be written as log of 3 square plus 1, where log of 10 is equal to 1. This can be rewritten as 2 times log of 3 plus 1. Okay. Then further we can say 2 times log of 3 has been given to us as 0.4771. I can write as 2 into 0.4771 plus 1. And we multiply this thing now. So 2 1s are 2, 2 7s are 14, carry 1. 2 7s are 14 plus 1 15, carry 1. 2 4s are 8 plus 1 9 and 0. 0 9 5 4 2 plus 1. This will become 1.9542. That is the answer. Next question. 3.4953 minus 5.2155 is dash. Right here. 3.4953 minus 5.2155. Subtraction. So this is 3 minus 5. That means you'll have to borrow from here, and this will become 4. This will become 13. 13 minus 5 is 8. This is 4, a number less than 5. That means again we'll have to borrow from here. This will become 8. This will become 14. 14 minus 5 is 9. This is 8. 8 minus 1 is 7. 4 minus 2 is 2. And this is 3 minus 5. Okay, that means we'll get a bar 2. You don't write minus 2, you write bar 2. So that means the correct answer is bar 2.2798. So bar 2.2798 is the answer. Next question, question 16. Half into log of 4 to the base 4 plus 3 times log of 2 to the base 4. We can write this as half into 1 plus this can be rewritten as, this is 2 over here, we read it as 4. So we have done this before also. We can rewrite this as log of square root of 4 to the base 4. This will be half into 1 is half plus 3 times, and we'll multiply this by half because power of square root is half. So half into log of 4 to the base 4. And this will become half plus 3 upon 2 into 1, which is 3 upon 2. So we can write this as 1 plus 3 upon 2, which is 4 upon 2. And the answer is 2. Question 17. If the antilog of 0.2198 equal to 1.659, then the log of 165.9 is dash. So anyways, here it is log, not antilog. So find the characteristics. So here there are 3 digits before the decimal point. That means the characteristic should be 2. So just look in this, which one has got 2 as the character. So this one. So that means our correct answer should be 2.2198. Okay. Question 18. 3 into log of 3 to the base 3 plus log of 9 to the base 3 minus log of 3 to the base 3. Okay, now we can write this as 3 into 1 plus log of 3 square to the base 3 minus 1. So it will become 3 plus 2 times log of 3 to the base 3 minus 1. 3 minus 1 is 2. So 2 plus 2 into 1, and that will be 4. So 4 is our answer way up. Question 19. Log of 75 plus log of 40 minus log of 3. We can rewrite this as log of 75 into 40 upon 3. So this first to follow log of m into n, that will give you log of m plus log of n. And the last one is log of m upon n, that will give you log of m as the full thing minus log of n. So division goes down, multiplication stays on top, gets multiplied. And this can be 3 1s are 3, 3 2s are 6, 3 5s are 15. And we get log of 25 into 40 in bracket. 25 into 40 gives us 1000. And log of 1000 can be rewritten as log of 10 raised to 3, which means we can write it as log 3 times log of 10 to the base 10. That means 3 into 1. Answer is 3. Last problem, question number 20. If log of 81 to the base x is equal to 4, then x is equal to what? To find out this, we have to learn we have to do an operation which we had learned probably maybe in the 9th or even at the start of 10th standard, wherein we learned how to convert from exponential form to the logarithmic form and from the logarithmic form to the exponential form. So this is in logarithm form. If you want to convert it into exponential form, how we'll do? Always remember the base in logarithm is also the base in the exponential form. And so this is the base. So base is here. Then the power will be on top, and that will be equal to some number. Okay. Now this x, the base will be here. This number that you can see will become the power, and this value you can see will come here. So something raised to 4 gives 81. We need to find out what gives. So for that we need to factorize this number. So let with the help of prime factors. So this goes in 3 times. Don't do 9 nines 81. 9 is a composite number, not a prime number. 3 times table. 3 twos are 6. 3 sevens are 21. 3 nines are 27. 3 threes are 9. 3 ones are 3. So we've got 1, 2, 3, 4. So that means if we write 3 is to 4, we will get 81. So in other words, x is equal to 3. So that means correct answer is 3. Okay. So this is a learn to convert from exponential form to logarithm. If we were to write the same thing, so now if we were to write this in the logarithmic form, how it would be? It would be log of 81 to the base 3 is equal to 4. Same thing as this, except now the x has a value over here. Okay. So with this we come to an end of this video. I hope you like watching this video, found it useful. If you like watching the video, found it useful, I would like you to do 2 things. First of all, hit the like button, share this. Second thing, share this video with your friends and as well as your classmates. They will also benefit like you have from this video. And do not forget to subscribe to the channel as well. Thank you very much for watching this video. Please give your feedback in the comment section below. Let me know how did you find this video, and if you want some other videos to be done as well. Thank you. Keep watching more such videos.